Thanks everyone for calling in to the VOLTTRON office hours. For today's meeting, we have Robert Lutz on to talk about the market service that is part of the VOLTTRON platform. We had some people ask about this at the last meeting. See, are those folks on? Dan, was that was that you, Patrick? Okay.
Patrick is here, and we appreciate you guys going over this well. And we have a couple of our dev guys on too, so ask some questions later. But
Okay, great.
Thank you for doing this.
Having a little trouble with your audio.
Oh, sorry. Let me make sure that's fixed. Can you hear me? Can you hear me now?
Yep, that's better.
Okay. Thank you. Yeah. So we have a couple dev guys on that we'll ask questions later, but I figured you'd just give an overview for people, and then we had some additional questions. But thank you for doing this.
Yeah, no problem. So Robert is a great resource. He's probably done the most VOLTTRON deployments of anyone at the lab, at least, and has worked on all sorts of different hardware and has a buildings background. So he's a good resource and can field a wider range of questions. And so with that, I'll turn it over to Robert just to kind of give an overview of the market service, and then see what questions people have. So yeah, thanks, Robert.
Hey guys, this is Robert. Can you all hear me?
Yep.
Okay, so the VOLTTRON Market Service is basically an agent. It's a service in the form of an agent that facilitates participation in markets. And currently it supports a double-blind auction style market. And basically participants in the market can bid in demand curves or price capacity curves for different commodities, and a supplier then can submit a supply curve. And the nice thing about this is when you inherit or join a market, basically the market service facilitates all of the callbacks to the different functions within the agent that allows participation in the market. And if you go to the read the docs page, it goes over that in more detail. But basically, there's a set sequence of operations in every market cycle, and this includes, giving reservations, saying I'm going to participate in a certain market cycle, and then giving offers, which means creating your demand or supply curve, and then the market clearing, which basically means getting the cleared price or cleared quantity so that you can make some either control decision or some other type of decision with that information. So the market service basically facilitates all of those actions. It handles the coordination of those callbacks. And so it kind of leaves the application or the market participant developer to deal with things like how do they describe their demand curve, and what type of model or other function are they going to use to do that. So like in our use case where we've used the market service is we will have a set of, and we're in the buildings domain, so we'll have a set of VAV terminal boxes, and they will create demand curves for air, cooling air, where the AHU, which is the air handling unit, will be a supplier of that cooling air. Now the AHU utilizes the aggregate demand curve from the terminal boxes to then estimate its electric demand. So it's kind of a tiered market. So utilizing the aggregate demand for air, it then can create a electric demand curve and participate in a higher electric market. And when that electric market clears, the price flows down from the AHU agent, or basically via the market actually, to the different VAVs, which then can make control decisions based on that price. And those control decisions are in the form of zone temperature set point controls. So that's kind of a high level overview. And certainly if you have any questions or anything was unclear, jump in now.
That was very helpful. One low level question on that is, are you, when you're running those computations, are you setting up your servers there, or using a cloud service, or what are you? What is your ideal way to actually compute with VOLTTRON?
Well, typically we're on a network that's segregated from the internet. We're communicating with real buildings and real building devices on our campus. And so we are actually on single computers, single computational nodes. Typically not high-end servers. We've used Intel NUCs, we've used Raspberry Pis and stuff like that. So for most of the applications that we run, they're not increasingly or highly reliant on high-powered hardware.
Awesome, thank you for that. I have a couple guys on my team that may have some questions. But if yeah, Naga, go for it, Naga.
Yeah. Hi, I had a question. How we where the VOLTTRON data resides actually? Is it in some Mongo some database, or are we converting them to CSV files or like that? It's a streaming data right now.
What was the question?
Where does the VOLTTRON
So
data reside?
where does the VOLTTRON database reside?
So it can.
The database for like where we put our data, or where we're actually getting our building data?
Where we put our data.
Historian data is.
It can be wherever you want it to be. So in the case of our campus deployment, we have a set of VOLTTRON boxes that are doing the data collection on the facilities network, and then they forward that out through some firewall exceptions to another VOLTTRON instance, a central VOLTTRON instance that's on the main network, and then the historian there writes it all to a crate database. And so you could also do an alternate one would be they could write it directly to a cloud service, or it really depends what the need of your use case is. Robert, does the market service do anything with historical data?
Your agents can. So there's a layer that actually does all of the, the market service facilitates all of the callbacks that create the demand curves and all that stuff. But there has to be something within the agent that actually tells it, how do I generate this price capacity curve? How do I predict, or how do I generate my demand curve? And usually that's based on real-time data, but there's nothing stopping a person from using historical data to generate that prediction. We actually use historical data to train models, but we do that in a offline manner, and then deploy the models. We're currently working on an agent that will actually do that in real time. That is basically, as time progresses and the models require retraining, that agent will pull the data, generate the new coefficients for these models, and then upload those to the agent's configuration store.
Okay. Yeah. Okay.
Thank you very much. That was helpful.
So in your case, I guess, what does your deployment look like? Are you going to have the split between collection boxes and
Yeah,
central?
well, so we're mostly working with batteries, and we're connecting them through the broadband network. And so we're seeing if we could try to push everything to. We have a partnership with AWS, and so if we could push most things to the cloud, and then pretty much could we grab the historian data out of push it to AWS and then manipulate it from there?
Yeah, it's whatever you want to do with it. So if you've got services up in the
Okay,
cloud,
cool.
then you could have the historian just push it to AWS, and then you do whatever you need to do there with it.
There's actually a Redshift historian, Redshift SQL historian, which is Redshift is a time series database built on top of Postgres that's available in AWS. That would be one way to go as far as a data store.
That's actually very helpful because we were looking at time series. Thank you very much.
Yep.
Yeah, we're actually in the process of employing some transactive type controls with both battery storage systems and thermal energy storage systems. We're starting off with some simulation testing, but we actually built a 40-ton, or I think it's 40-ton thermal energy storage system behind one of our campus buildings, and it's fully integrated with the building. So we plan on doing a lot of experiments with that.
Very interesting. I would be interested in following up on that. Do you happen to have any of, and I've asked Mr. Hack this a few times, but would you happen to have any battery simulation data that's come off of VOLTTRON?
You know, I could inquire on that. I know they built a simulation model for one of our buildings that has a battery in it for integrating with some transactive systems. But as far as I understand, the battery is the battery model that they're utilizing in this Energy Plus simulation isn't very sophisticated.
Well,
So I
and
don't know exactly what you're trying to do, but it may or may not meet your needs.
Well, and I sent a question to Lucy about her battery, but I never heard anything back. Do you know what the status of that is?
No, I would talk to Shweta.
Shweta? Okay.
Shweta wrote our battery energy storage system and thermal energy storage system transactive agents, and she's in the process of doing some simulation testing on those.
Okay.
So she could definitely give you more information. I don't know if.
Oh, she's on the call.
Yeah.
No, I'm in the process of testing it. I've just started testing, so
Yeah.
probably in a week or 2 weeks time, I should have something for you guys.
So maybe at the
Yeah.
next office hours you could go over it.
Sure.
What were we? What were you?
I don't know. Depends
Well,
on what is actually needed.
yeah.
What were you interested in the modeling aspect? Like.
Yeah, so just a little background for people that haven't heard me talk before. Y-Green is an energy exchange application that's connecting the utilities to the batteries on their network. And so if we could have the utilities view that the batteries has a virtual power plant, and then use VOLTTRON to communicate with those batteries to turn them off or on to charge or discharge back onto the grid, that would be what we're aiming to do. And so in building our database, our dev team would, we're currently using the consumption data that you sent, Jeremy, and
Okay.
so we're using that as kind of an outline, but we would like to get it with the actual battery data, pretty much to be able to turn on and off batteries with VOLTTRON, and then add the market on there as that second layer. But first step is just really being able to control them.
Yeah, I think that the model within Energy Plus that they're utilizing, the basic parameters are its current state of charge, and then basically a charge or discharge status. So like, what are you controlling it to do? And so that's why I was asking. It doesn't sound like you're trying to do anything that's super complicated, and I think the batteries are relatively simple. If you were trying to do like frequency regulation or something like that with the battery system, this type of model probably wouldn't do anything, wouldn't do what you want it to do. I don't know if you know
Yeah,
much
that's
about
kind
it.
of probably down the road.
Do you know much about Energy Plus?
Yeah, that's definitely down the road. Not much, actually. No,
It's not a high
I can.
resolution. It's not a high resolution simulation tool. Basically, it's more for looking at like longer term control intervals, and it's really good at, or pretty good at doing like the thermal and some of those aspects of a building system. But basically, the minimum resolution or the minimum time step is 1 minute, and even that's pushing it for Energy Plus. So that's what we utilize is 1 minute.
Okay, that's fine. We're looking at that in that range, so that's not too bad. So we can dive deeper into that as well. So thank you for that resource.
Yeah, no problem.
I have a quick question. If we have two batteries in two buildings, we are connected to VOLTTRON devices. So how we are gonna? What is there any specific unique identifier to contact that particular battery in one particular device?
On one deployment node or between deployment nodes?
Between, I mean, between deployment nodes.
And so
What is the unique thing?
well, the platform,
Yeah, that we can connect. We can communicate with that particular battery.
well, it depends on what you're trying to do. So basically, each platform is going to have a unique VIP address and identity. And then on the platform, each agent will have its own unique identity. And so if you've gone through the steps to set up basically the remote hub sub remote RPC, basically connecting the platforms, then you can do RPC calls to agents running on a different platform via their VIP identity, or you could publish data to that other message bus or grab data from that other message bus.
I think what he's trying to ask is how do you control a particular device? So we have topics associated with the device, and you can control via that, right? You can use that to say the topic has typically a string of devices, campus, building, an actual device, and set of points. So if you have a unique identifier for each of the device, then the string remains unique. So you can do an RPC call to master driver to access that particular device and that particular point. You can either get the data or control the device. Does that answer your question?
Yeah. Thanks for that.
Okay.
All right, I was way
Thank you
off
very
there.
much.
That's not what I thought he was asking.
Yeah, we're just going through the steps of adding a device. So we want to make sure people can add the device to the network and then give that utility control over that device. So that was a helpful summary. And I'm just curious, does that for the next office hours, is that possibly something we could go over? No worries if not, but or we can talk.
Could you say that again? What topic were you interested in?
The you had asked her if and I didn't catch her name.
Shwetha.
Shwetha, nice to meet you.
I think they want to go over the topic of remote procedure call. I mean, probably it will be best if we can go over the master driver topic.
Okay.
And show them how to scrape data off of devices and how to control devices.
Sure. That sounds like a good topic. Okay. Sounds good. Thanks. Yeah, and then any updates on the battery work would probably be interesting as well.
So based on the description I gave you, did the market service sound like something you're interested in utilizing, or would it fit?
Probably probably in, the more complex market is probably our stage 2, our first one. I was thinking of if we could actually simplify the model, because we're instead of having a bidding system as our very first run, we're just going to give the utility complete control over it. So I think we could just simplify the bid curve to just say if it's connected automatically, be willing to do. But yes, our second phase is this auction where we're creating the marketplace for the batteries. So the same way your marketplace for the AC will be our marketplace for the virtual power plants.
Cool.
Does that make sense?
Yeah.
And I was planning on having to develop this all of ourselves before I found VOLTTRON. So I really appreciate you guys going out ahead and doing this. It's made it very easy for us to connect with things. So
Yeah, that's great. That's the goal of the project, and why we've been funded by DOE, and we're always looking for new use cases and additional people to work with it. And as you're using it, if you run into any documentation issues that are confusing or whatever, just let us know. And if there's as new use cases come along, if there's places where a new feature could be added to the platform that would benefit the community for that use case, that's also something we're interested in hearing about. So yeah, so great. Thanks for calling in.
And to add to that, we've been doing some work with a variety of different market types and market systems. And one of the things that we're trying to do is there's some deficiencies in the actual VOLTTRON Market Service that I wouldn't call them. They're just kind of limiting factors where it doesn't support certain market types, and there's some scalability issues. So we're trying to look at now creating, either expanding the VOLTTRON Market Service or creating some type of unified market that is more robust and basically supports more market types.
sounds good. Thank you very much.
All right. Okay, well, thanks. That's a good conversation. Any other questions or topics people want to discuss? If not, then we'll call it an office hours, and then next time we will review the master driver service and talk about RPC calls between agents, and how to, agents can expose services themselves, and they can make use of other agent services. So that we've talked about that in the past, but I think it's been a while, so that'll make a good topic. All right, thanks everybody.
Thank you. We appreciate it. Have a good day.
Yep, you too. Bye.